Hi everyone. We're going to be learning about alkenes and alkynes today. So hopefully you're finished your alkane worksheet and now you can start on the alkenes and alkynes. So alkenes, we're going to start with alkenes. They contain at least one double bond in a carbon chain. So they are considered to be unsaturated. So whereas alkanes are saturated, the alkenes are going to be unsaturated. And just so you know, how we write a double bond is just like an equal sign, okay? So we'd have like a carbon on each side and then a double bond in between them here. Now, general formula is CnH2n. So if we look at that, let's say we had C50. That means how many hydrogens you'd have? You would have 100, right? If you had 100 carbons, you would have 200 hydrogens. So it's always going to satisfy that chemical or that formula there, that mathematical formula. Now, when we talked about alkanes, all the names ended in ane. Now all the names of these will end in ene instead. All the other aspects of naming are exactly the same. The only thing that is different is that the numbering of the carbon chain has to start from the end that is closest to the double bond. So you have to find where the double bond is, and that's where you're going to start your numbering from. You also need to indicate the position number of the double bond. Okay, let's just go through some examples here. So I'm going to draw it out and we're going to name it. So, oopsie, I forgot to put my glove on. I have to wear like a little mini mitt while I do this so my hand doesn't make, so my stylus works properly. Okay, so CH3, I screwed up already, look at that. So CH2, and then I'm going to have the double bond, CH, CH, CH3, and CH3. Now, looking at this, one thing you'll note is that we've got two hydrogens on this carbon. That is because carbon, as we know, only makes 4 bonds. So this double bond counts as 2 bonds. So the first carbon here has 2 bonds because of that double bond. And so it only has room for 2 hydrogens from there. I'm just going to erase that. Yeah, there we go. Okay, so when we're looking through this, now we need to figure out where to start counting from. So you're going to start counting from the end that is closest to where the double bond is. So obviously the double bond is closest to the left here, so this is where I'm going to start counting from. And as per usual, we find the longest chain. So 1, 2, 3, 4, that's going to be my radical. Now, just one thing to note, the double bond must be part of the parent chain. So even if there's another chain, maybe that's longer, you have to have the double bond in the parent chain. So 1, 2, 3, 4. The prefix for 4 is bute, so that means that the parent chain for this is going to be butene. So instead of butane, as if it was an alkane, it would be butene, and that tells us that there's a double bond. Now, as you can see, the double bond is between carbons 1 and 2. So you're going to pick the lowest number always. So that's just a general rule for organic. You're going to find the lowest numbering combination always. And so even though that double bond is between 1 and 2, you're going to name it as being on carbon 1. Okay, now we have a methyl group also that we have to name. So the name of this is going to be 3-methyl-1-butene. And so remember, there are always dashes between letters and numbers. And so this 3 indicates where the methyl group is, where the radical is. This 1 indicates where the double bond is going to be. Okay, try another one. Let's go back to red. Okay, so CH3, CH, I'm going to put a group here. Oops. CH, and then I'm going to throw my double bond in here. Okay, so looking at this, Now, I have to figure out where my radicals are. I have to figure out what the longest chain is. So if we count and remember that longest chain has to have the double bond. So 1, 2, 3, 4, 5, but we have to include this one because remember chains can bend, right? So the longest chain is actually 6 carbons in a row. So it's going to be hexene as my parent chain. Now, where am I going to start numbering from? The left or the right? Now, this is the radical. So even though the radical is closer to the left, the double bond is closer to the right. So this is going to be carbon 1, 2, 3, 4, 5, and 6. So when we find the name of this then, it's going to be 5-methyl, because this is a methyl group. Dash, now again, that double bond is between carbons 2 and 3, so I'm going to name it as carbon 2, and then hexene. Good. Okay, we'll do another one. Let's go back to red. All right, so CH3, CH, CH3, CH, CH2. Okay, now this is using that different notation here. When you get questions like this, I would recommend redrawing it. So just right away, I would take that and do this, because that's what that means. Sometimes when you leave it in this bracket notation here, people can get confused by it. So I find it best to just redraw it how you're used to seeing it and then go from there. So again, where are you going to start numbering from, left or the right? It's going to be the right because that's closest to where the double bond is. So 1, 2, 3, 4. So the name of this, 3-methyl 1-butene. And as you'll note, that's the same, oh, where'd it go? That's the same name as what we did before, but it looks different. It was just drawn backwards. So remember, it's really important to remember that these molecules exist in real life. So much like yourself, you can look at you facing forward, you can flip yourself around and from the back, right? So these molecules can be flipped up and down. They exist in real life. So you have to imagine them as being 3D, even though obviously we're only doing them in 2D on our papers. Okay, we will do another actually, let's try drawing one. So let's try drawing 3-methyl 2-pentene. So looking at this, again, what I would do would be immediately just look at the parent. So this is your parent here, 2-pentene. So you're going to draw 5 carbons in a row. So 1, 2, 3, 4, 5. You know the double bond is on carbon 2, so that tells you it's between carbons 2 and 3. Next, you're going to look at your methyl group here, your radical. And on the 3rd carbon, you're going to have a methyl group. So now your last step is to fill in the H's, fill in the hydrogens. Now don't let the double bond mix you up. Remember, carbon only ever makes 4 bonds here. So this first carbon here already has 1 bond, so I need 3 hydrogens. The second carbon here has 3 bonds already, so it only has room for 1. Now this carbon in the middle here, we've got 1, 2, 3, 4. Oops, that's a single bond though. Hold on, let me erase that. So that's a single bond. So we only have, oh, hold on one second. So we're doing this and we need to, sorry, Mr. Turk was at the door. we need to look at how many hydrogens we have. So this one has no room for any hydrogen. So no hydrogens there. It's already made 4 bonds. This carbon here, the 4th one, has 2, and our last carbon has 3 to fill it out there. Now, so you just always have to count the hydrogens. Yeah, okay, thank you. You just always have to count the hydrogens. That's the main thing. Now, molecular model. So I just threw this in here. If we were in class, I would have you play with the model kits, which is kind of like Lego for chemists. So it's really fun. Sadly, we don't have that opportunity. If you take chemistry in university, if you take an organic chemistry class, it probably would be helpful to buy a molecular model kit. Helps you visualize things. Some people are really good at visualizing in their heads. Other people struggle a little bit. Anyways, so I wanted to show you what these things actually look like in real life. So this is the alkanes here. So 1 carbon, 4 hydrogens. In real life, this is what that molecule would look like. Okay, so we draw it in two dimensions, but always remember it exists in 3 dimensions. And so just take a look through these little figures here. This is pentane. So as you know, pentane, it kind of has a zigzag pattern here. And again, if you take chemistry in university, you'll end up learning about these shapes and everything. Double bonds here, we show them like that, so they sort of like fold over on themselves, and they really change the shape of a molecule. Again, you would learn more about that later on. I just wanted you to be aware of how the models work here. Okay, now we're going to look a bit at alkynes. So alkynes, it's essentially the same thing as alkenes, except instead of a double bond, now we've got a triple bond. Again, these are considered to be unsaturated. The general formula, CnH2n minus 2. So for this, if we had 100, for example, hydrogens, you'd go 2 times 100 is 200, minus 2, 198. Okay, if we had C50, multiplied by 2 is 100, minus 2, 98. Okay, so it's always going to satisfy that formula there. So the ends, instead of ending in ane or een, will end in ine. All other aspects of naming the same, etc., etc., and then you indicate the position number of the triple bond. So let's go through a couple examples here. All right, so okay, oops, forgot that. Okay, so looking at this, again, you're going to start numbering the longest chain from the end that is closest to where the triple bond is located. So in this one, clearly this is on the left here, so I'm going to go 1, 2, 3, 4. That is my radical here, and again, I always circle it just so I don't forget about them. So 4 carbons in a row is bute, is the prefix, and the ending for this is going to be butene. So the name of this molecule, 3-methyl dash, again, the triple bond is in between carbons 1 and 2, so I'm going to name it as 1. You always go to the lower numbering combination, and the parent chain, butene. Okay, so 3-methyl 1-butene would be the name. Be sure of the dashes and commas; those all count for marks and grades. Like they factor into the name of the molecule, so be sure of them. Hold on, how many things did I do? Oh yeah. Okay, so let's try drawing one. So I'm going to give you this one: 4, 5 dimethyl 2 hexyne. Okay, so when you're doing these, you are going to first look at the parent. The parent is hexyne, so 6 carbons in a row. You've got a triple bond. I know it's a triple bond because the ending is YNE, and the triple bond is between carbons 2 and 3. So 1 carbon, 2 carbons, and then between those, I need a triple bond, 4, 5, 6. So looking at this now I want to look at the radicals. So on carbon 4 and carbon 5, I have a methyl group. So that di tells me that I've got 2 methyl groups. So on carbon 4, I have a methyl group, and a methyl group is CH3. And on carbon 5, I have a methyl group, which is CH3. Now, again, does it matter if I drew it top or bottom? No, it doesn't matter at all. They're the same things, because molecules can twist as well. Okay, so now we just want to add in our hydrogens. So I'm going to have 3 here. Now, the second carbon, if you look, it's already got 4 bonds. So 1 here, and then 3 from the triple. So I don't need, or I can't have any hydrogens here. Same as for the third carbon here, already full. This one can have 1, this one can have 1, and this last one here can have 3. Okay, so that's the alkynes. I'm only going to do the 2 examples because it's essentially very similar to the alkanes. The only thing different is that is the double and triple bond placement piece. Now we're going to talk about isomers. Isomers, I think, were referenced in the first worksheet, so now you'll be able to go back and answer that. So isomers are compounds that have the same molecular formula but a different structural formula. So, for example, C5H12, all of the molecules that we're going to look for here have the formula C5H12, so they all have 5 carbons, 12 hydrogens, but they're arranged in a different way. So same formula, molecular formula, but their structural formula is going to be different. They're arranged, and I'll post a video on isomers for you guys to check out too. Okay, when you do these, you have a couple different strategies. The first strategy is to determine, is this an alkane, or an alkyne? And how you're going to figure that out is by looking at that formula. So which formula does it satisfy? Remember, alkanes are CnH2n plus 2, alkenes are CnH2n, and alkynes are CnH2n minus 2. So if I look at C5H12, hopefully you'll be able to see that that satisfies the formula for an alkane. So that tells me that this particular molecule is an alkane, which means all the bonds are single, they're all saturated. Now, what you have to do is you have to figure out how many different ways can you draw 5 carbons and 12 hydrogens, all using just single bonds, and they have to maintain that formula. So it has to be C5H12. Now, the most simple way to start for this, I always find the most simple way is to just draw the 5 carbons straight across. So incidentally, I always find this interesting. I'm sort of average at isomers, but some people are just so fast. They can just see it really clearly. Some of us, we struggle a little bit. So whoever you are in there, where you fall, don't worry about it. If you're struggling, you'll get better at it. Just need to practice. So first step, I would just don't worry about hydrogens, right? So I've got 5 carbons in a row here. And then I'm going to name it. So you'd always want to name it. So this is going to be pentane. And the naming will tell you often if you've done it correctly. So I'm just going to do the carbons first, and then I'm going to fill in my hydrogens later. Sometimes the hydrogens crowd it up, and it's a lot of times it's easier to see. It's easier to see just with the carbons. So now you have to think, how else can I arrange those 5 carbons? If you want to pause the video and try to figure out yourself, that would probably be great. So please do that to find the other 2. This is the first one. See if you can figure out the second 2. Okay, hopefully you've paused and you've done it, and now I'm going to finish up for you. Usually the strategy I like to use is you take one of the carbons and you move it over so that it becomes a radical. So for my second one, I'm going to draw 4 carbons in a row, and that 5th carbon, I'm going to make that into a radical. And if I were to name this, I can now call this 2-methyl-butane. So 2-methyl-butane. So looking at that, I would start my numbering from here, right? Okay. Hold on, let me get rid of those. Actually, I'm going to get rid of that too. Okay, so now we need to find our third one. Now, often what ends up happening, and I'll just do this in orange, someone will try to put it over here, and then they'll try to name it 3-methyl-butane. But why can't you do that? So that would be wrong. You can't do that because if let's just do this. if I moved that here, what's the name of that? It's still 2-methylbutane. So you've just flipped the molecule. It's not a new molecule. You're just looking at it from the back now. So that's why you can't do that. So that will not work for that. This last one, a lot of people struggle with this one. What you end up having to do is you have to take this carbon here and move it over. Move it there. So you end up having, oh crap, hold on, sorry. You end up having 3 carbons in a row, 1 up, 1 down. Let me just get rid of this stuff here. So, and then to name it, the name is going to be 2,2 dimethyl propane, because you've got 3 carbons in your main chain here. Now, what you have to do is, unfortunately what happens here is that some people forget to fill in their hydrogens. So you have to go back and fill in your hydrogens here to make it all correct. I'm just going to do that quickly and sloppily, apparently. And again, this one here, the middle carbon, doesn't get any hydrogens because it's all full up. So these are my 3 isomers for this one. Now, before I give you your assignment here, so alkenes, just so you know, some of the ones in your assignment, I think, give isomers using an alkene. So just before we start here, an alkene, remember, you can move the double bond. So I would play around with moving the double bond, making radicals, etc. So do what you can there. And of course, as always, ask questions if you need. So worksheet number 2 is assigned. So take a look at that, see what you can do. I will also post the answer key online for you guys. Okay, thanks a lot.